Hi folks, welcome to this lesson on indefinite integrals. In the last lesson we looked at some antiderivatives, and one of the examples we had was this one right over here. F of x is 3x squared plus 2x minus 3, and we found the antiderivative is x cubed plus x squared minus 3x. And we checked that by differentiating the antiderivative and seeing if it got us back where we started. And the answer was yes, it did. But what if, for our antiderivative, we had said plus 1 at the end? Would it still have differentiated to 3x squared plus 2x minus 3? It would. Or if we had had plus 2, or plus pi. There are actually an infinite number of functions that differentiate back to the original. So since the derivative of a constant, there are actually infinitely many functions that differentiate to f of x. The indefinite integral, or integral with no boundaries, represents all of these possibilities. It's sometimes called the general antiderivative, but typically what it means is the simplest antiderivative plus something we're just going to call c. And c is the constant that we probably don't know the value of, that could be tacked on to this simplest antiderivative. It's the constant that comes from integration, which is the process of finding this antiderivative. And so a constant that comes from integration is called, wait for it, the constant of integration. Now this whole symbol here will tell the story eventually of where all these symbols come from, what they really represent. But for now, let's just consider it to be sort of a verb that says antidifferentiate with respect to x. So what does that mean if we see the indefinite integral of 2x and it says dx? So again, that tells us that we're antidifferentiating the x variable. Well, where does a 2x come from? An x squared. Okay, and you could double check. If you differentiate x squared, you'll be back at 2x. But that's not all. Since it's a general antiderivative, or an indefinite integral, is what we should be saying, there's this plus c that we tack onto the end. So if you can find an antiderivative, and you can write the letter c, then you can find an indefinite integral. It's really just what we did in the last video with a plus c on the end. We'll nitpick a few extra cases here, but that's really all there is to it. So let's think about this first one. We've got x plus 2. What's the antiderivative of x? It's going to be its power goes up, and the flip of it, new power, goes down front. 2 comes from 2x, and here's our constant of integration. What are we going to do? We're going to check, and this can be informal or just in your head. But if I were to differentiate this, I'd end up with x plus 2, which is great. That gets us back where we started, so we must have antidifferentiated properly. Let's try another one. I'm thinking of the wheel of trig, in which we differentiate clockwise and we antidifferentiate counterclockwise. So in this case, it's the antiderivative of cosine is going to be sine. Now, when you antidifferentiate, just like when you differentiate, the constant stays. So it'll be 2 times sine of x plus c. So don't forget the plus c here. And then I could check that derivative by that antiderivative, or that indefinite integral, by differentiating. 2 would stay, sine would turn into cosine this time, and I'd have 2 cos x. The c would just go to 0. So we've done it correctly. So if you want to move up the chain, if you're at f prime and you'd like to find f is just the indefinite integral of f prime. Okay. Just like antidifferentiation, integration moves us up a level. But when we use the indefinite integral, we're accounting for the fact that there may be a constant that we don't know. We kind of know about its rate of change, but we don't necessarily know exactly where it's located. So here we're going to have the antiderivative, or the indefinite integral here. And they're so close together, it's hard not to use similar terminology or to sort of get them not confused, but think of them as one process. So 1/2 is going to turn into 1/2 x. Okay, this the 3x squared is going to turn into the 3 stays 1/3 x cubed. Now, if you just looked at 3x squared and said, "Oh, I know that comes from x cubed," that's great. Anytime you can skip a step, please feel free. X cubed is going to turn into 1/4 x4, and we have a plus c. So f of x is going to be 1/2 x, or you can write it as x over 2, plus x cubed minus 1/5 x to the 4. And I have to be honest, I'm not quite confident that that's the correct answer, so I'm going to check. This will be 1/2. Get 3x squared. I'm really good at differentiating, so that makes this check really easy. Oh, which is where we started, so we must have done this correctly. And so far, we have no way of knowing what c is. Let's take another one. We could bump this up a level. So we've got the second derivative. The first derivative is just going to be the indefinite integral of the second derivative. So you can think of the only difference between an indefinite integral and an antiderivative as having a plus c. This is going to turn into 3x plus c. Great. We want to bump it up again. Well, let's take the indefinite integral of the first derivative, which we now know. So f of x will be the indefinite integral of 3x plus c dx. And I actually do it. So when I actually perform the integration, or the antidifferentiation, that's when I drop the dx. So power goes up by 1, flip of the new power in front. The c, well, is going to turn into cx. And now I need another constant of integration. So some people will call the first one c1 and then another one c2. Or you can use a different letter. You can say d. Doesn't really matter. And so I get 3 over 2 x squared plus cx plus d. That's sort of all the function forms that have a second derivative of 3. And it makes sense. It's a parabola that opens upward. Its second derivative, or its concavity, is going to be a constant. Now, all this talk about antidifferentiation and finding indefinite integrals might make us think about product, quotient, and chain rules, which we have for differentiation, and say, how do those work when we're integrating? Well, there are analogs to those things, and we'll deal with some of them. Like for chain rule, we'll use substitution. But the simplest play is just to change stuff into easy to integrate form. And that's especially true of rationals. So we've kind of been through these gags before with differentiation. Let's imagine this first one here. I could try and integrate it as is, but what's probably a better plan is just to distribute, or FOIL, and see what we get. We'd get 2x squared plus 6x minus x, so that's plus 5x minus 3 dx. Once it's in that form, it's easier to find the antiderivative. So if we're doing it with the rules, we'll say 2, power goes up by 1, flip of the new power goes in front. We'll say 5, power goes up by 1, flip of the new power goes in front, minus 3x, and of course our plus c. And then we'll simplify that a little bit. 2/3 x cubed plus 5 over 2 x squared minus 3x plus c. And we'll probably check. Okay, so if we differentiate, we'll get, let's see, those 3's will divide out, so I'll have 2x squared plus 5x minus 3. We're back where we started. We must have found the correct antiderivative, so we must have found the correct indefinite integral. For the next one, we've got something that looks like a quotient, but because there's only an x on the bottom, we can use a special property or a simplification trick. We can split this into x to the 4 over x minus 2x to the half over x, all dx. And I think the first one is easy to figure out. X to the 4 over x is x cubed. x to the half over x to the 1. When we simplify these, we subtract the exponents. So you're going to end up with minus 2x to the negative a half. That is an equivalent statement for this little rational over here. And once it's in that form, it's no big deal to antidifferentiate or to find the indefinite integral. So power goes up by 1, flip of the new power goes in front. Next one, power goes up by 1. So we were at negative 1/2. Up 1 from negative 1/2 would be positive 1/2. And then I take the flip of the new power and put it in front. So that would be 2. The flip of a half is 2. And then plus c. That'll give me a quarter x to the 4 minus 4x to the half plus c, which I'm going to check by differentiating. So I'd have 1/4 4x3 minus 4 1/2 x to the negative 1/2. And that would give me x cubed minus 2x to the negative 1/2, which is what we had in this stage right here once we simplified it. If you want to, you can try and put it back together and make that initial fraction. We feel pretty good once we have it back to a form that we got to maybe in the first or second step. There's some practice around this on page 437, numbers 1 to 9 odd, 10, 11, and 12. I hope that you found this helpful. Good luck with the material, folks, and take care.